Example 13 says, we'll find all the solutions of the equation ln of x squared equals 5. So I really like this problem because it shows if you don't really fundamentally understand how logs and exponents work, that you can very easily do something that looks completely logical but actually come up with the wrong answer. So the first thing I want to show you is a very common wrong way to solve this problem, right? We can always learn a lot sometimes by doing things incorrectly because it's going to look right, right? So somebody who is very clever with logs would be like, oh, I can make this problem a lot easier if I pull the exponent down front. So they would start with the original equation. They would pull the 2 out front. And then they would divide both sides by 2. Raise both sides over e, and say x equals e to the 5 halves. And some of you right now might be like, I don't see anything wrong with that. What happened? So the problem is you actually lost a solution doing it this way. So you want to be careful about pulling even exponents down in a situation like this, because this is a quadratic inside of here. So quadratics can have 2 solutions. And because this is x squared, right, even if x is a negative number, it immediately turns positive when you square it and plug it into the problem. So the correct way to do this is don't pull the exponent down front. If I raise both sides over e, I get x squared on the left and e to the 5th, oops, on the right. And now when I take the square root, I get plus or minus the square root of e to the 5th, which, to compare it to our previous answer, plus or minus e to the 5 halves, right? Because square root of something is the same thing as raising it to the 1/2. So you actually had 2 answers. Now, some of you are like, but Kelly, you told me I can't have negatives inside logs. Well, that's true, but what we said is any value of x you plug in has to make the entire expression positive. And this works. Positive e clearly works, but if you plug in the negative case, it immediately gets squared and becomes positive. So the domain of this function, if I just said f of x equals x squared, the only value that won't work here is 0. So the domain of this is actually all reals except 0. So be really careful. So this is a problem I really like to show you how to do it both ways, because this looks completely logical and valid, but you're missing half the story if you bring that 2 down front. So let's find all the solutions to this equation. So just like we did in the previous problems, right, we said, well, we want to combine all these logs. But notice here that I have logs on both sides of the equal sign. So in the similar way, we said, well, if we can get a number in the form of same base equals different things, right, we were able to just pull the exponents down. We can actually do that with logs. If I have log base b to some expression m, and it's equal to log of the same base of a different expression, then the stuff inside must equal each other. So what I can do here is I can combine all the logs on one side and then combine all the logs on the other side and hopefully get to this form. So these 2 things are being added. So on the left, I multiply these 2 expressions together. So I'm going to say x times x plus 1. So that's x squared plus x. And that equals log of 6 on the other side. Now I'm in the form that I want. I have the same basis on each side. So I can say, well, I could raise each side over 10 and cancel the logs. But if I do that, you end up in the same place as just setting the insides equal to each other. So this is this property in action. So that's what's going to happen. Once again, I have a quadratic, and this factors into x plus 3, x minus 2 equals 0. So x could be -3 or +2. Once again, this is a log expression, so I have to verify these answers. And if one of these answers doesn't work in any part of the original equation, then it's invalid for the whole equation. So -3 is not going to work because you can't have a -3 inside of a log. And if I plug -3 in here, I'm going to get -2. So it fails in two different places. So -3 is out, but +2 works just fine.